Now, there's the other side of it. When we look at this planet, our planet, it seems solid, right? Wherever you're sitting, just thump the earth with your feet. You find solid earth, right? When you walk on the roads, when you walk on the streets, everything below you seems solid. So we have the impression that planet Earth is an absolutely solid planet. Well, yes, in its mass it is solid, but in actuality, it is an extremely fragile planet. It is such a delicate planet that you realize by the end of this course that it needs all the nurturing that it can get from people like you. Let's find out what is the fragility of this planet. To start with, we need to look at the atmosphere. That thin layer that you see there of blue color, that is the atmosphere of planet Earth. That's as thick as it is. Now imagine the globe in the lab in your school. You have a globe, a model of planet Earth, right? And imagine there is a thin coat of varnish on that globe. You know how thin that will be? Now, you know how thin that is relative to the size of the globe, right? That is exactly the thickness of the atmosphere on planet Earth. I give you the example of the globe so that you can understand relative to the size of the planet, the size of the atmosphere is very, very, very thin. And here starts the story of the fragility of our atmosphere in relation to our planet Earth. So we're going to go back to our science lessons and to examine the relationship of planet Earth with the sun. So we have the solar radiation in the form of light waves that passes through the atmosphere and it reaches the planet. Now, most of the radiation is absorbed by the Earth and it warms the Earth. It passes through the atmosphere, as you can see there, and it warms the Earth. Now, some of the energy is radiated back into space by the Earth in the form of infrared waves. And this is good because we don't want too much of infrared rays on planet Earth. Now, some of the outgoing infrared radiation is trapped by the Earth's atmosphere and it warms it. This warming of planet Earth by the trapping of the infrared radiation is what is called global warming. Imagine you sit on the ground, you crouch on the ground, and you put a blanket over yourself. You'll feel warm, right? That's what the atmosphere is. It's like a blanket over planet Earth. It warms the planet just enough so that you and I can be comfortable. You and I and the plants and the birds and the bees and the butterflies, all of them can live a comfortable life on planet Earth. Now, something else is going to happen soon. While we said some of this outgoing infrared radiation is trapped by the Earth and warms it just enough, something else interferes with this whole process. What you're seeing on the screen is smoke and pollution from all the industries on the planet. So what does all the smoke and pollution do? We are spewing 155 million tons of man-made global warming pollution into the thin shell of our atmosphere every 24 hours, as if it was an open sewer. Now imagine the place where you live, next to your house, a huge river is opened up and all the sewage water from all the houses flows through that. Will that be comfortable? No, because you can see it and you can smell it. Unfortunately, when we spew 155 million tons of global warming pollution into the atmosphere every 24 hours, you're not even aware of it, right? That's an open sewer that we're not even aware of. But now, because of global warming, we're becoming more and more aware of it. So what happens? When all that pollution goes and settles in the atmosphere, that thin blue line, which is the atmosphere, it becomes much thicker. When it becomes much thicker, what happens? A lot more of the infrared radiation is trapped by the Earth's atmosphere, which means there is a lot more warming of the planet, which is not desirable for the planet. Why is it not desirable? Let's make a comparison. Here are the two other planets who are close to us. Venus, and we will talk about Mercury soon. Venus and Mercury are about the same size. Venus is just about 400 kilometers in diameter, bigger than planet Earth. Now, look at the atmosphere of planet Earth. Look at the atmosphere of Venus. You can see Venus's atmosphere is much, much thicker, as a result of which, when the sun's rays hits Venus, it traps in much, much more quantities of infrared radiation. In fact, it is so hot that on Venus, if there is lead, lead will melt instantly because of the heat. So what are the temperatures? The average temperature on the planet Earth is about 15 degrees centigrade. And Venus, it's 464 degrees centigrade. So you can see the difference, right? Between having an atmosphere as thick as it is on planet Earth and as thick as it is on Venus. Now, Mercury also is about much, much hotter, about 167 degrees centigrade. Now that's because Mercury is also much closer to the Earth, to the Sun. So it's likely to be much more hotter, right? So now you've seen the difference in temperatures of a planet when the atmosphere is much thicker. So you understood the correlation between the size of the atmosphere and the temperature on the planet. The thicker the atmosphere, the more hot it will get. Earth, as of now, is 15 degrees centigrade. We have to see whether it'll stay that way for much longer.